Hi and Assalamualaikum. Okay, so for this presentation, my teammates which are Naim, Naqib, Khairunnisa, Aliah, Nurizatul and myself Syafiqah are going to present about chapter 11, which is about investigation of pipe bombs. Okay, so first, what is pipe bomb? Pipe bomb is an improvised explosive device, IED, which consists of a pipe, an initiation mechanism, and also an explosive. Pictures that are included in my slides are example of pipe bomb. So, in the middle is a classical pipe bomb, which is a steel pipe nipple with a threaded cast iron end caps. And other than that, there are also pipe bombs which are made from PVC and also ABS pipes. Okay, so pipe bombs are very dangerous weapons designed to kill or injure person. Following the explosion, physical evidence which are the container, initiator and explosive are very important evidence that help forensic scientists. However, in addition to the physical evidence recovered from pipe, the pipe themselves can provide a lot of valuable information. There are three types of evidence that we can get from the pipes, which are the pipe classification and identification, pipe fermentation, and tool marks on pipe. For pipe classification and identification, in this slide, the picture actually shows the end cap of pipe. So basically, from the pipe and also the end cap, we can identify whether it is still intact or fragmented. We can measure the diameter of the pipes, the wall thickness, and also the thread pitch, because all of this is consistent for a specific nominal diameter pipe. Other than that, we can also examine the industrial markings and also track the manufacturer and sale outlets. So basically, from all the information we get from the classification and identification, we can track down where the pipe come from. Okay, so for this slide, it's just a picture that shows the example of pipe with its countries of origin stamp and also UPC sticker. Next is the pipe fragmentation. The physical nature of pipe fragments can actually indicate whether it uses high or low explosive. Based on the slide, there are two pictures which are example of low and high explosive. So the pictures actually illustrate the damage to the similar steel pipe that caused by low and high explosive. So low explosive typically produce a large pipe fragments, but the line is not precise and it tends to split the pipes rather than shatter them. As we can see from the example, for low explosive, we can still see the shape of the pipe. But as for the high explosive, everything is shattered into tiny pieces. Last but not least is the tool marks on pipe. Pipe surfaces may bear characteristic tool marks arising from manufacturing process and also from post-manufacturing manipulation or alteration. So this marking actually provides significant physical evidence relating pipes to the manufacturers or to the specific tool used by a bomb maker. So as you can see from the picture, there is an accidental tool mark left by a vise on a pipe, so it can be a special characteristic for identification for that particular evidence.
Hi, this is Naim. So now I'm going to continue about the biological evidence on pipe bombs. Biological evidence may survive from an explosion. This evidence also can provide information about the bomb makers and handlers, but it has high risk of contamination during searching and recovery procedure and subsequent processing. For biological evidence such as fingerprints, there is a research conducted by Ball et al. 2004. Based on the research, they find out that fingerprints could be recovered from post-blast pipe bomb fragments using cyanoacrylate, which is superglue. The fuming was conducted on scene and latent print development was undertaken in the laboratory to be examined. The fragments tested were recovered from both metal and PVC pipe with end caps, which were usually the person hold the pipe bomb. Next is DNA analysis. Based on the research conducted by Eslinger et al. 2004, they successfully demonstrated recovery from post-blast pipe bomb fragments of DNA profile who matched subjects who handled metal and PVC pipe. In this research, 10 subjects each handled one metal and one PVC pipe. Out of 20 pipe bombs, 4 gave matching subjects' DNA profile and another 8 also matched but were below reportable level. For laboratory search and recovery procedure, we have opinion from 3 sources. The first one is Benson et al. 2001. They said if explosive residue present at the same place with fingerprint and DNA, then we need to extract the residual explosive first if feasible. But if extensive manipulation of evidence required or solvent extraction appeared to be necessary, then the superglue process was conducted first. Then only the DNA analyst swabbed the pipe fragment. Based on Bureau of Alcohol, Tobacco and Firearm (ATF) laboratory, they encourage cyanoacrylate fuming in the field as the best way to preserve fingerprint and DNA. Even when the solvent extraction is required for residue recovery, the presence of reagent contaminant is known and can be accounted for. But for Bile et al. 2009, they reported that cyanoacrylate fuming did not have a measurable effect on the success of the DNA analysis after either 1 week or 3 months. However, the most important step is consultation between chemist, fingerprint, DNA analyst and investigator before proceeding. None of this examination is mutually exclusive.
In pipe bomb initiation, the methods of initiating pipe bombs depend on the nature of the explosive. A flame or hot wire normally will supply sufficient energy to initiate low explosives and primary high explosives, while a secondary high explosive requires a shock wave from a detonator. Initiation may be instant or delayed. Delay mechanisms may be commercial and some are homemade. For flame, the most common initiation device for a pipe bomb filled with a low explosive is a burning fuse. It burns at a nominal rate and produces a jet of flame to initiate the main charge. It is commercially available for pyrotechnic, industrial, and military applications. Commercial and military safety fuses have a black powder core within fibrous and plastic cylindrical tubes. Expanded safety fuse is usually recovered after an explosion. Pyrotechnic or cannon fuse burns almost completely, leaving primarily a trail of combustion products after ignition of the device. Hot wire is another effective initiation mechanism in which glowing filament supplies the necessary energy to initiate a low explosive. Electrical fusing systems require a power source, which is usually a battery, wires, and a means of completing the circuit. Next, blasting caps are designed to initiate explosives with a shock wave that produces detonation. The cap may be initiated by flame from a burning fuse, by a built-in hot wire, which is electrical initiation, or by shock tube. Fuse, wires, and minute fragments are recovered, examined, and compared to standards to enhance the scope of investigations. In electrical components, the most common are battery, associated wiring, and a switch to complete the circuit by sending power to a blasting cap or hot wire. It is usually attached to the pipe with adhesive tape. Switches range from simple mechanical throw switches through motion and light sensors to high-tech electronics. The greater the complexity of the initiation system, the more physical evidence remains.
This is Naim, and I will continue on the presentation on timers and switches. Commercial electronics clocks and cellular phones may be used as switches. These components are usually recoverable and can be reconstructed and traced. There are also a wide variety of homemade mechanical and electrical switches that can be employed as booby traps by response to movement. Scene searchers and scientists should be familiar with the internal component of the variety of timers, switch, relays, and cellular phone, and have access to physical and photographic databases in order to recognize the significance of such post-blast evidence. Next is about wires. Wires and connectors should be carefully described and the wire and the insulated diameter recorded, along with the number of strand and insulator colors. Wire can be tracked and compared based on measurement, colors, marking, and stenciling. The insulation color of detonator wires indicates the type of detonator. Next, I would like to talk about adhesive and adhesive tapes. Pipe bomb makers often use glues and adhesive tapes to attach elements of the fusing and firing system as well as sharpener to the pipes. Glue, adhesive, and adhesive tapes usually survive an explosion and can be compared to the material in the possession of a suspect. Adhesive tape also may carry physical evidence such as fingerprints, DNA, fibers, hairs, and debris. There are three types of analysis of glues and adhesive. The first one is IR spectroscopy, which is the identification of the binder and many inorganic pigments. The second one is PGC and MS, which is for greater certainty in binder comparison and elemental analysis. And the last one is SEM and EDS, which is the elemental analysis of inorganic pigments. That is all from us today. Thank you.